I am ready to go, Lorna.
We need one of the lights. We would want that one.
Okay. 150 by the way, 180. Okay.
But like I'm saying, if we want
$150. And then we could buy an SRT.
Okie dokie. Sorry to keep you. A few odds and ends. Tomorrow, office hours, I'm moving to 12:30. So 12:30 to 1:30, I'll have my office hours instead of 1 to 2. I have a dentist appointment at 2, so I kind of have to go whenever I want to go. And then I won't have any office hours on Friday. I'm sorry. I know that's when your assignments due. Brandon will be teaching this section and the other section. And I will be at the Oregon Computing Committee chair or something. Not really sure. Yeah, it's the OCCC. So that's where I'll be. I think I have to miss one other day this quarter, and that'll be it. This quarter I always have to miss 2 days, one for OCCC and then one for Meat Cop selection. So, unfortunately, I'm sorry, but I try to get somebody to teach for me. He's going to do file I/O. I think Brandon feels comfortable with file I/O, so that's what he's going to do for you on Friday. Let's revisit this quiz. Because I felt like maybe we were a little shaky on this, and then I guess having that question come by from Paul made me, or saying that there were people in his office, TAs including, that were kind of confused on this subject, and I thought, this isn't really good. No, I'm not lying to you. There are sometimes I may be wrong, but I don't blatantly lie to you, I promise. And if I'm shaky or I don't know something, I'll typically tell you, or I'll know if I told you something wrong. But when it comes to this virtual stuff, I'm not lying to you. It is called polymorphism. You have to make the function virtual. You don't get polymorphic behavior unless you have a pointer. It's the whole purpose of having polymorphism. There is no polymorphism if you don't have a pointer. Okay? Because it's not getting dynamically bound. Remember, the whole thing with a pointer is it's getting something later. Okay? It doesn't have its value now. So let's see how I want to do this.
So does that mean it waits to, like it compiles, but then it waits to do anything until the pointer says, hey, do this?
Yes. Mm-hmm.
Okay, so instead of being on the stack, all of our stuff then becomes on the
It becomes references rather than actual things because it doesn't know its types. So when you guys are seeing this V table, la 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 la, it's the virtual table, and that's all it has to be set up so that it knows based on reference of what goes on. Okay? You'll learn about that in assembly language in 271.
Okay.
Okay? Because that's kind of the nitty-gritty details of what's happening on the stack. Okay. So, trying to think how I want to structure this. I think I'm going to put, one extra slide in here. And first, just make sure, since I don't get to talk to you on Friday, make sure we're all set up correctly. So assignment 3, your whole idea, guys, is that you have card games, okay? And before, you had a Go Fish. Now, I don't know if you called it Go Fish, or I think some people were calling it game, but you had something there, okay? That was your Go Fish game. And at that time, it had private, or it should have, because we want to have our members private to provide encapsulation. So we had a deck, and we had some kind of players. And I don't know whether you did a vector or you did something of you have these players later that you allocate however many player objects you need. Then you had some kind of, you better have some kind of start game. Okay? And when we were in your main, okay, so you're in your driver, and you knew at that point in time, this one has a relationship, okay, because these were classes, this was a class, and that was the relationship we established in assignment 2, okay? Then you had something where you said go fish or game or whatever you called it, G, and you started your game, or you had to somehow start your game. This is how it should have been implemented, okay? That's really all you needed in there. Now, at that point, this is not polymorphism, this is static binding, early binding, whatever the heck you want to call it. We're making a go fish object G, right? Now, when you have extra classes, right? So now we're going to have a poker. Poker is going to have the same things as these right here, okay? Because all card games actually have these things, right? So since all card games have these things, then you make it protected, and now your deck goes over here. And this goes poof. And you don't need it in here. You shouldn't have it in there, right? Okay, so that goes poof. It got put over there. Because it's protected, we are still providing encapsulation here because they're really basically not accessible unless you're a part of this class or you're inheriting from this class, in which the details don't need to be removed from you anyway. Okay? Okay, so now you need to have in your poker, you also need a start game that's unique for it. Because their games are played differently. They both have players, they both have decks, but they're played very differently. All right? Poker is a card game. Go Fish is a card game. Okay? Now, if you were to make a Go Fish directly, or you made a poker directly, so say for instance, we could still leave this right here the same, okay? This isn't going to throw up at you, and indeed you're not going to need a virtual function. You don't really care. Start game doesn't even need to be in card games. Why?
Because you're just running Go Fish.
Because we're just running Go Fish. Even though it's inheriting the stuff and gets deck and all of this, we don't have to have it there because we made a statically bound Go Fish object. Therefore, it's only looking in Go Fish for a start game. If it didn't find it in Go Fish, then it would look for it in its parent, because that's what inheritance is. Okay? But it didn't look in its parent first. That's not the way it goes. All right? Now, because this is what the whole topic, I guess that was in Paul's office and what I sent out in an email, I'm just making sure you really understand. So this will not give you a compiler, it won't give you anything, it'll work all poof, great. But you're not doing polymorphism. So why the heck would you even have a virtual? You don't even have an abstract class, right? Like, I mean, right now we don't because we don't have one pure virtual function. Okay? So now if we need something polymorphic and we don't know, because think about these game sites that are online that carry hundreds or thousands of games. They're not going to create all of these games and then say, which one do you want to play? They're going to create the game you're going to play, and that's the only game they're going to create. Okay? So we've got a card game, G. Now we know we're going to have to get to start game, right? But now we're a base type card game, so it's going to say, well, I could have been a card game, or could have been poker, could have been go fish. I don't really know right now, and this start game is going to throw up at you. It's going to say, I don't see a start game, right?
You do G equals.
So now we do start game. Okay? And we put that in there. Now all of a sudden, when G decides to take on something, such as a new poker game, now all of a sudden, oh, well, we're going to, because we're at this base type, we're going to go up there and look at their start game. Okay? If you wanted it to say, hey, this game, this start game, is really defined in my other classes, and in this case, is there anything to start a game with just regular card game? We don't even know what kind of card game you're playing. No. So now what that becomes is this, basically do nothing, right? And that's what's considered a pure virtual, because it didn't do anything, okay? It was just purely there for the simple fact of having to have it there so that this would be okay. Okay? Does that make sense? Now, a student did ask me in my office hours, could you have in here made a poker P and a go fish F, and then when you knew what you wanted to do right here, could you instead say get a P? Is that still polymorphism?
Not really, no. It's just static or statically binds the things and then says, okay, we're going to put this in here. Right?
No, this is still polymorphism. This is what the slide was on just from the other day, right? I'm just showing you in a different scenario. Now, this is kind of idiotic because now we're carrying around in our program 1,000 games. Do I need to make 1,000 objects to only use one of those objects in my program? That is stupid, right? Now, we have two here, and of course I am not going to take off if you were to do this because I don't stipulate that, except that I do say make a new poker or a new whatever, and of course people go amok with what I say anyway, so I don't really know why I make rules in this class or anything else, but you're human. It's okay. So it's still polymorphism. It's just that, and because I could have done address of F, then G would have needed to act like a go fish. In this case, it needs to act like a poker. That is polymorphism, guys. G is morphing into whatever object later. Okay? Because presumably you have that in an if statement of who you're going to give this to. So you don't know until that thing runs of whose address it's getting and pointing to. But this is always what makes polymorphism. This is not polymorphism. Okay? The poker object and the go fish object are not polymorph. They are what they are. Okay? I'll tell you, this is probably one of the biggest questions if you're a CS person that you will get on an interview. What is polymorphism? Explain to me polymorphism. That's really, because for some reason this topic is hard for students to wrap their head around, and I'm not sure why. It's just something that changes, right? an animal, right? I may go to the pet store to get an animal, but I get there and I love any kind of animal. I don't know whether I may have gone there with the intent of getting a dog, but until I leave, I might have had a bird or a cat. Right? That decision morphed. And think of that as being decision. That was a decision, and that was a polymorphic thing. You morph all the time with stuff, right? So try to think it. The best way to understand all of this is to put it in the context of real life. That's what this stuff is all about, is to model real life. That was how it came about, okay? So, I don't know, hopefully that helps you with some of this. And then if you had something like a Connect 4, right? That was my other one. So then you get, so this is your is-a. Right here, this is my is-a relationship. So you can have and is-a's in the same, with all your classes, right? You've got lots of these different relationships. If you had Connect 4, then you might have something like a board game, right? And maybe now everybody has players because that's a card, because that's a game in general. This may have a board. Protected. If you hose yourself, though, what I'm noticing here has a board, okay? So it has a board. This one has a deck. Maybe we have a game class now, right? Then you have a game class that has your player, and this inherits from game, and this inherits from game. So they both get players, but only board games get boards, and only card games get cards. But both games will always, no matter whether you're getting a Connect 4, a Go Fish, or a poker, you're going to get players. Okay? Now, we put players having to have hands. Maybe we don't want players having hands. But this is the idea. Now can you see, if you get this design wrong in the beginning, it is a nightmare. I'm seeing that if you got design wrong in assignment 2, your assignment 3 is going pretty rough for you. Because the whole idea of OO is designing first. Knowing that you got this design and everything set up properly in the beginning will help you continually use all this stuff over and over and over. All right? I've had students asking me about this. Multiple inheritance. And multiple inheritance in Java was kind of a big thing. Your book pretty much says just stay away from it. Okay. I think it probably has its uses, just like anything. It depends. But I would say until you get a little bit further into your C++, I would stay away from the multiple inheritance. Okay? I was going to show you a little bit about it. Okay, so I have poker. Okay, I'm going to take this play out, okay, and I'm going to show you that, say, for instance, you are trying to inherit from card game and gamble. So I'm trying to figure out a situation where you might want to say, okay, I want to get all the features of card game because I'm making a card game, but I might want to get some of the features and get some ability and some things out of gambling type of card game versus just a card game by itself. Because you don't have to gamble when you play card games, but other stuff comes in when you gamble. Okay? So I was trying to set up this type of scenario for you. And So in here, and this is how I test stuff. This is how simple it gets when I'm testing stuff for you guys. So I'm like, okay, what happens when, and the student asked me, when we inherit from two classes and they have the same function names in them or even members, what's going to happen? And this is where multiple inheritance gets a little crazy, okay? So I took the void out. Took the play out. Let me go into card game has a play. I could put something in here if you want me to, but notice it just does nothing. Will it ever need to do anything? Well, I'm just going to say something in there. We'll just leave it like this. Okay, so it just does nothing, all right? My gamble has dollars, because I was thinking, well, that's something I could think of that would be in gambling that I would want to add in addition, right? Because I could see this logic. Hey, let me inherit from two places, right? So I can get my dollars and get some other functionality from gambling along with playing the card game. So then I have my void play right here, right? And, and if we go and look at what I have in there, I actually have something so I know that this particular gambling one was called, okay? So at least the gamble play does something, the other one doesn't, okay? Are you laughing about my little... I have to have fun too, you know. So now let's go to play games in here. Now I was trying to set up multiple different scenarios for you, okay? So I was thinking, what if I made a card game, okay? And then I made a new poker, and I want to get to play. What if I made a poker object and tried to get to play? And what kind of situations am I going to run into with any of these, okay? And so let's look for this one. Let me see if I have my big long thing in here. Okay. So that was all the little things I need, and hence why we need a makefile, because... Okay. Now what do you notice it says in here?
Request from a replay is ambiguous.
It's ambiguous. So basically it's telling me, hey, here, I don't know which play to get to, right? On 7 and on 8.
In gambling card. Yeah.
Right, that there are two different plays, one in card game and one in gamble.
Right.
Now, what do you notice about the ones from above?
They didn't get it. That's correct.
So let me, right, because notice my error was on this, okay? So I wanted to play and said, okay, what if we don't make a poker, because that was my next one. I wanted to see what happens when I was trying all kinds of different scenarios. And there is no way to directly get to something. I heard somebody say that to me too. And I'll show you. This is where I'm showing you what goes on. All right, so let's do this one. And what do you notice? Both of them gave me something. It was a valid program. Let's go back and look at it, right? Both of them gave me something. Play, we did nothing. So remember, we didn't have the little C out of anything in there. It just did nothing, didn't print anything. But it did do it. It didn't give us an error. And the other one that was gotten for us was play the gambling one. What do you notice about what happens? What's going on up there?
They've got arrows.
They have arrows, but what do you also notice about them up above? Right, they have a base class. Okay? So they have a base class, and so really they can look at that base class for this play, no matter what they get. It got a poker, but even though I got a poker and my base class was card game, I'm going to get card games play. I can't get over to Gamble's play. I'll never be able to access their play. Okay? If, though, when I make a direct object right here, why can't I go to play? So does this make sense, guys? Does this make sense why I'm going to play in the right play? I can't specify which play. I can by making different pointers, but I can't any other way. Okay? And if I make a poker one directly, then it's going to say, bam, you don't have a play. Why did it say, bam, you don't have a play when I made a poker object directly?
Because it goes and it says, oh, look at these two exact plays that I have.
Well, what did it do? When I make a poker object right here, when I make this object,
Oh, that doesn't have a play itself.
it doesn't have a play itself.
So
What did I tell you about public play out of when inherited things? When things are inherited, what happens with them? They're pulled down into the class itself. So that would be like trying to pull in a public play, or trying to pull in play that was defined in card games and a play that was defined in Gamble. Right?
Right.
And that's not going to happen.
that's two plays.
But when we make them on the heap,
You're fine.
then we don't care, right? Because they'll go back to their base class.
So it will pull in both of them, but it will just go back to the base class.
Right. So I can't make it go to the other play. I tried all kinds of things. I was told you can, but you would actually have to go into you'd have to do it all by reference and addresses and and you'd only do this in like an OS situation. But I tried like normal syntactic way, and there's not a way, okay? So now what if I wanted this play to work and I had an inherited one, right? Now what could I do? Where was it, my poker? Now my poker has a play. Let's uncomment this out. And now what should I get?
Say poker.
Right. So now I get one that does nothing, one that says isn't good, right? One that says poker. Is this ever going to pick anything else?
No.
No. That play is always going to be picked because it's a static object, and when it's a static object, it's going to go to that place first and then get to its parents. Okay? So now that I have a play defined there, it didn't try to bring in the inherited plays. It didn't try to bring in the two from the inheritance, okay? What, though, I'm also, when I'm making a new, what am I doing wrong? Why am I in here? So this is just a little bit of a review and asking you questions. Why in here, how can I make this morph? So in neither of these cases are we morphing. Why are we not morphing? Well, first of all, we didn't have a play defined. But now we have a play defined in poker, and we're now not morphing. Okay? So notice the only time I can get to poker's play is by making a poker object. That's
Right.
we have something trying to morph, but it can't. What do we need to do to make it morph?
Gamble and card virtual plays.
Card game. And this one. So we need to make this a virtual. And what was my other one called? Card games? I don't think I've gone in there. Now, is this one doing anything?
No.
No. What can we do with it?
Just have it see out. Oh, that makes sense.
Okay. What, by doing this, what did we do?
We made it abstract, or made it appear virtual.
Pure virtual. Okay? So now this is a pure virtual, and card game is wideness abstract class. Those are your terminologies. Okay? Because these can be things on the next test. All right. We made the other one virtual. Now what do we hope to get? Poker, poker, poker. And now they've all polymorphed into poker. Since there's so much terminology, I'm trying to do this so that to help you with this. Is our, what did we call the other one? Is our gamble class an abstract class?
No.
No.
Why is it not an abstract class?
Have a pure virtual.
Didn't have a pure virtual because its play was actually doing something. Okay? Now that could be a real scenario, right? Because maybe the play for the regular poker inherited from the card game, maybe that play is just a play that you want to play without betting, right? But you don't want to redefine a play. The gambling one could have a play poker for gambling, right? Or still play, but it would do that functionality, okay? But card game by itself wouldn't have any functionality. Does that make sense? So that would not be an abstract class anymore. A gamble wouldn't. Okay? All right. Now, are we all on board with that? Did that help at all? Because that's all that's inheritance. We're done.
Okay.
I'm not returning. Okay? All right. Now, here is, maybe I can let you out a little early today. So, this I think could be cool, just, it's definitely a little hairy, okay? And you can get scoping issues, and you might not get scoping issues. Because that's what the first thing out of my mouth to the student that asked was, the reason I went and tested all this is because I said, I bet you get a scoping. Of course you're going to say, you know, scope of play in the same place. Of course, you only get that when you make poker by itself and it doesn't have its own play. Now I can intelligently talk about it a little bit more. But that's what I want you guys to do too. Go out and explore. Make very, very tiny, tiny programs that do absolutely nothing but give you an insight what the heck's going on. All right? Okay, so here's something really cool. I didn't get to teach this last quarter because we had the Wonder Board, and that's as far as we went with it. Any classes or any of that kind of stuff in the prior 162s. This is so flippin' cool. I mean, overloading is pretty cool in itself, okay? And you only get these in object-oriented languages. Python lets you overload. Well, I don't know if all object-oriented. I don't know if you got to overload in Java. I'm getting kind of confused now. In different languages, but it's pretty cool, okay? Because before, and I've got to start now. I'm going to be flipping and talking a little C and a little C++ at times because I am going to be moving you into the C route, all right? Because last 2 weeks of this class is C. So in this situation, okay, in C++, we're allowed to overload, okay? So I could have two functions with the same name that are defined to do basically the same exact thing, it's just with different types. And so I could call this swap, but I could call it with ints or I could call it with characters. This is ingenious. Loved it. Because in C, when we had to do this, you could still kind of make this functionality, but you actually had to call it swap ints, swap chars, swap, you know, whatever it was, because every one of them had to be a different name. You couldn't have two functions with the same name and the same scope. Okay? So we all get this, right? Wouldn't it be nice if we only had to write this? Because swap is, by all intents and purposes, these two are the same exact thing, aren't they?
Yes, they are.
Wouldn't it be nice to not have to do that and only write it once for any type that comes in? Because now that we have classes and stuff, these don't have to be ints. They don't have to be characters. What if they're objects we want to swap? We might want to swap the values and stuff inside of an object. So now that we have user-defined types, this sucker could get crazy with all of these that we have to define. We'd love to have one and only one. Well, guess what? You can in C++. And this is all you do for it. So they're called templated. You get templated functions and you get templated classes. Okay? We've already used a templated class. I'm going to show you that next. What was our templated class? I heard it. Good job, vector. That's exactly right. So we're going to write our own vector templated class in this class, just like we did with our own string. You've used it, right? Somebody had to write that. Basically, if you get into a job and you got to write your own libraries, now you can write your own string library. You can write your own vector library, right? Because sometimes you're not allowed to use libraries. You have to write stuff from scratch. Okay? I thought this was interesting. Listen to what one of my TAs was telling me. For some of you, when you think I'm crazy when I say stuff like that, one of my TAs, when he was up at Intel, he said that they were, number one, Intel makes them do everything from scratch, a lot of stuff from scratch. But can you believe in his team, he had to use GCC as their compiler for what he was developing instead of the Intel compiler? Why? That was a good question, right? Why? He said because Intel makes even their teams working at Intel buy the licenses for the Intel compiler. And so to save money, they would rather have, use the GCC and just use that and get out the assembly and the stuff from GCC than use their own. What he was trying to say, too, this was his point to this, because sometimes they do develop their own stuff. But in this case, this point was sometimes you got to do what your boss just asks you to do. And you guys have got to get over this. When I ask you to use a certain compiler, a teacher asks you, don't question it, do it. You cannot at Intel question, hey, why can't I use what I want? Because I said to use GCC. You're going to get fired if you question them. Sometimes there's a good reason, okay? So rules, you need to be better at following rules. You just really do. And not questioning sometimes the rules and from certain people that they come from, right? You can question your friend that wants you to jump off the bridge all day long, okay? And you could question in certain other areas. But stuff like that, when I ask you to compile on the server, and that is my requirement, compile on the server, guys. Okay. And I want to put you on Intel, but after this story, I got to go find out if we've got enough licenses for Intels, because I'm all worried now. Because that's when Paul brought it up. He's like, "Well, did you know?" And I was like, "Oh, great day," because I was putting it in the lab for this week, and I was like, well, "Scratch it out." Okay. So here's a template. This is really cool. You have to have this. Just get over it. Okay. It's just there.
Does that go before every?
It goes before every stinking thing, yes. It's one of those that just has to go there. It has to go before the declaration, so before the prototype. Now, if you did all of this in the same place, it would only be there once. But it also has to go again before the definition. Just to make sure. Okay, so you have to put over every single thing. Whatever you put it over there, you have to put it over, okay? I have no idea why they call this class T. Don't ask me why they came up with this syntax or these names and did this when you're templating a function and not a class, but it just is. I guess it makes kind of an object, template object. Yeah.
Would it break if you said template class T and then template class F? Would it then just not at all?
Well, it's two different types.
They're two different types, so you can specify different types. You don't have to specify by saying it again, but you can say comma class. Pretty sure I'm getting this right, the syntax. But yeah, it doesn't have to be a T. This can be anything. T's for type, though, but what I'm trying to do is a T1 there, so you can see one's a T and one's a T1. This is if you have many different types in here. Notice in here we were using all of the same types. Nothing in here were two different types. Okay? If they were, then you can say how many different things are we templating here. Okay? But you could use F and T if you wanted to, but you're going to have to make sure those F and T's go with the right F and T's. Okay? That N's are F's, and they're going to always be F's, and this was going to be K's, or however that needed to be for your stuff. Yeah.
So is this a C or C++?
This is a C++ thing. Anything crazy like this, anything that seems like fluff, that is going to be C++. Okay? Anything that seems like, dang, this is going to make my life a lot easier. That's going to be C++. That's why I'm going to spend 2 weeks with you at the end to make sure you get prepared for 261, because I think that helps you out tremendously in 261. Because you guys have been using C++ for so long, you're going to carry some things in there and go, dang, why won't this work? Dang, why won't this work, right? And so I do want to make you a little bit aware of those. Yeah, so you just put that above, and now this thing can be swap with ints. It could be swap sending in characters. It could be swap sending in anything you want, right? When can you get in trouble? I want to point this out. When could you get in trouble with this? So one thing they talk about is, you do have to think about if you're bringing in arrays. And say if this were a swap and these were array parameters here, just remember that swap functionality can't be the same as the other swap functionalities, right? Because those values have to be swapped. Otherwise, you're just going to make one pointer point to a different pointer. You're going to swap where they point to, which that may be useful too, because that's like you swapped the values, right? But just be careful, okay? What have we seen? Vectors, you said. This one's pretty easy to understand because you've seen this. And so you can just say, once again, it's the same stinking thing. It's not like a function or a class is different. It's still this template class T for your type, okay? And then T becomes this type. Remember, we made a vector of ints, or we can make a vector of characters, or a vector of objects, right? So everywhere in this vector class, we were either making that, remember, it's just a dynamic array in the background. That's all the vector class is. It's just a type that gets put on it at the time when you create the vector. And it can change what kind of types. And how they did this is by saying, let's make this a templated class, and we will say we don't know what this is going to point to, the type. We don't know what we're ever going to push back onto something. There's where a type would be again, right? And then these would be, notice I do not have this up above these. I don't have the type specified there. The T is wherever you would need to see int put or char put or whatever, okay? And this, though, I'm going to leave it like this. We're going to get that element to push on, and this is what you will write for me in lab. Maybe not next week, but the week after. I don't really know how I'm going to put that, because I need you to do file I/O too. Yeah.
So could we make a template that's in a .h file with a bunch of templates with all their functionality in it?
That's exactly what you do. Yep.
Okay.
Just remember that when you do this, and this is your .cpp file, this sucker has to go up above all of those too. This was your .h file. Had to go in both those places. Just don't get confused there. Okay? And then how did we use this? How did we want a vector? We just said vector of, and this is where the template goes, ints, if you were in main, right? And that's why it was a templated class, because you could make it a vector of anything. Okay? All right, go have fun.
So
I didn't let you out early, did I? Yes.